on LinkedIn Live and YouTube. So hello everyone, good morning, good afternoon, or good evening everyone, depending on where in the world you're zooming in from. We're going to wait just another minute to give everybody a chance to join, and then we're going to get started. While we wait, I would encourage everybody to use the chat button, tell us where you're zooming in from, and say hello.
Thomas, I see Keith. Yeah, in
There you go.
list.
I added Kit. Hello, Kit. You are now unmuted.
Hello.
Hello. Okay, I think we can get started. Kit is now also here as a panelist. So, hello, good morning, good afternoon, and good evening, everyone, depending on where in the world you're zooming in from. Today, we are going to have our LF Decentralized Trust with the DSR Corporation and Kit from Hashgraph about the Hiero and ACA-Py Plugin for the Hedera Ledger. My name's Tomasz, and I'm an ecosystem manager at LF Decentralized Trust. So before we begin, and if you joined any of our previous webinars, you know that we have some housekeeping rules to do. So first, I would like to emphasize that everyone is welcome in our community, and we strive to create a safe and welcoming environment for everybody. So please follow our code of conduct when interacting with each other on this webinar, as well as in the broader community as well. You can find our code of conduct on our website and on our wiki. As all of the Linux Foundation webinars, this webinar is kept under the LF antitrust policy, which you can also find on our website and on our wiki. The webinar is being recorded as well as being live streamed on YouTube and LinkedIn Live. So welcome to everybody joining us from there as well. You can find the recording along with the slides on our webinar library. You can follow this link to find about the recording and the slide. Now, we encourage everyone to be as active as possible, and the more activity we get, the better experience for everybody. So please raise your hand to get unmuted and to speak up. And you're also welcome to use the chat button or the Q&A button if you would prefer to type your questions in, and one of the panelists will address them as we go along. For those of you joining us on YouTube and LinkedIn Live, feel free to either use the comments section and the questions will be relayed to the panelists, or you are also welcome to join the live webinar, and I will be sharing the link there as well in a moment. Now, without further ado, I would like to introduce Kit, who's a Director of Product Management at Hashgraph, and Alexander, who's a lead software engineer at DSR Corporation. So Alexander and Kit, over to you.
Thanks, Thomas. Yeah, give me a second. I will share my screen. Slides.
Okay, I see Tommy said the chat is disabled. Just give me a second. I will fix that immediately. There we go. Now you're able to use the chat as well. Thank you for pointing it out.
Great. So yeah, let's get started. You should be able to see my screen. So here's our LFDT webinar on Hedera ACA-Py Plugin and Hiero project, presented by Alexander Shenshin, it's me, and Keith Kowal. What we have on agenda for our webinar today. First sections are overview. So first of all, SSI review. Just to note that I know that some of you may be very familiar with SSI or decentralized identity, but still we have a broad audience on LFDT, so I will try to keep this overview short. On LFDT, there were already very great, very extensive sessions on SSI concepts. examples and on other webinars and workshops. So if you have any questions on SSI concepts, you can just type them in chat. We will address them at the end of the webinar. And I will also share a link to other, I think it was Hyperledger event where we get really great presentation about SSI concept. I will share something that I usually share with people when they ask me about SSI. But for this webinar, we will go through rather quickly. Next, we briefly touch AnonCreds, ACA-Py topics. So what are these pieces? What are their benefits and advantages? Why we're building ACA-Py plugins? Why we support AnonCreds? Then we'll talk about Hiero and Hedera Ledger. We will go through Hedera ACA-Py plugin itself, the main topic. Discuss some under the hood design and integrations, and I will show a short demo of ACA-Py with Hedera plugin. Then there is a section about what are the benefits for community from our point of view, why we're building it, why we think it's great, what's next section with some roadmap and a small announcement on next events, and separate Q&A session where we can address all your questions from chat or by voice. And let's get started. First of all, SSI review. So self-sovereign identity, SSI, sometimes referred to also as decentralized identity. Just to quickly understand its concepts, we need to compare three digital identity models. The first one is centralized identity, so-called. So it's a very common model. And first one actually. So this is when users have accounts in some systems or organizations or just on the website. So each user has an account where he fills his information, has a separate password for each website or service, and information is stored on the side of separate organizations' websites. The user has a lot of such accounts. The second is third-party identity provider or federated identity approach, where we use some identity providers such as Google, Apple, Facebook to log into other services. So comparing these two models, so the second model, federated identity, is more convenient. It has better UX, so you don't have to create a lot of passwords, remember them all. You don't need to duplicate your data across different services. But still, both of these approaches are not very good for privacy, because in the first case with centralized identity, your data is stored on individual services and some databases. For federated identity, it's better because it's stored on a single identity provider side, but still, users do not have control over his data, actual control. So the data is stored on third-party service. And self-sovereign identity, SSI, what we're talking about today. It's a different model. It defines three roles, as you can see: issuer, holder, and verifier, and it leverages peer-to-peer interaction and communication. And what's important here, in this case, the data that user is a holder role. So the data that user is going to provide to any services, and services, they are a verifier role here. This data is stored on a holder side. So user actually stores the data, and issuer has some party that can sign on a data that is related to a user. It just provides a signed data to a user, and user then controls this data and can share it with any parties and any services that he wants. Yeah. So other very important part here is that self-sovereign identity is, first of all, it's an approach and a concept. It's not a library and not a specific framework. So it encompasses multiple specifications, standards, frameworks, and tools that implement SSI principles. And you can see an image on the left. The idea here and the concept is that you as a user in a center here. So you are in control of your data. You decide when to share this data, with who, how much data is shared, and you store it on your side. Key differences here, as I said, from centralized and federated identity. It leverages peer-to-peer communications. There is no need for centralized intermediaries, no need for passwords to just log in and retrieve your data all the time. And data holders own their data and decide when and with whom they share it. Here is also some interesting comparison between federated and self-sovereign identity models. So federated identity model is commonly built on OAuth and OpenID. And here we can see that we have this, the very important difference here is that an issuer, so in principle for federated identity, we can also define three roles: issuer, holder, and verifier. So issuer could be an identity provider, holder could be user, and verifier could be some reliant party, so some service that wants to retrieve some data about the user. And the difference here is that for federated identity, verifier needs to interact with issuer directly because the data is stored on the side of an issuer, on the side of identity provider. And in case of self-sovereign identity, there is no need for that. So everything is done peer-to-peer with holder in privacy-preserving way. So holder can autonomously control the exchange of credentials and data with any verifier. Here is a simple SSI use case. So we have Alice as a holder with some party, and she installs a certified mobile wallet application on her phone, first of all. So in self-sovereign identity, we use wallets to store the data. And a side note here is that a mobile wallet, for example, there is an European Union Digital Identity Initiative that was approved, and basically it creates an obligation for every EU state to create a mobile wallet according to UDI model. And so this is not some new concept for geeks, it's an actual concept that's being adopted in many countries. So first of all, Alice installs a certified mobile wallet application on her phone. Government issues a digital ID, passport, or driver license for Alice. And the digital ID is stored in Alice mobile wallets. And then Alice is getting on an airplane and need to present her ID. She presents her digital ID from the mobile wallet directly. So in this case, Alice is in control of her information and decides what parts of that information other entities can see. And this common SSI use case can be extended. And here we can see some other features that are possible with SSI. So for SSI, there are online and offline cases. So someone can create an SSI system to share credentials offline. Issuers could be not only governments, but businesses as well. Verifiers also governments, businesses, individuals. Wallets can be provided either by a state or a third-party one, or third-party service. Wallets could be really different, mobile, cloud, or hybrid. Issued credentials can be anything: digital ID, know your customer, transport tickets, concerts, yeah, anything else. There's also a very great feature, selective disclosure, that is possible with self-sovereign identities. So you can disclose only a part of the data, or even a predicate with certain credentials formats. So you can, for example, share that you're over 21 years old, but do not share your actual age. And root of trust of such systems, you can see here verifiable data registry. I will talk about it in the next slides. It can be anything. It can be blockchain, some other decentralized ledger technologies, some trusted web, DNS service, and etc. So regarding specific SSI technical concepts, it's two concepts here: verifiable credentials and decentralized identifier states. So verifiable credentials, you can see here is the diagram from verifiable credential data model. It's WPRC recommendation from 2022. Yeah, you can see 3 roles here, as we discussed before, and verifiable data registry as a place that is a root of trust and also shared data storage for all the system to operate. Verifiable credential concepts, it's quite simple. So verifiable credential is a set of claims about the holder, usually signed by some issuer. Kind of authorizes this data to be issued to a holder. It's a similar concept with real-life documents, paper ones. So in case of passport, the issuer is a government and holder is a person. So this is the same concept. And passport is essentially a set of claims. And yeah, use cases for verifiable credentials can be really extensible. And it just takes to determine who is an issuer, who is the holder, and who is the verifier for each specific use case. And the centralized identifiers concept is a bit more tricky. So here we have this small diagram about decentralized identifiers. So we have DID, it's decentralized identifier that refers to some DID subject. And well, it's identifier, but in a contrast to typical identifiers that are used in other identity models as well, we have an important part here called DID document. So DID resolves to DID document. The DID document contains some metadata about DID subject. Yeah, it can be public keys associated with a person or organization that is DIDs refers to. And both DID identifier and DID documents are recorded on verifiable data registry. And as I said, it's a root of trust and it's also an abstraction. So verifiable data registry can be a lot of things. It can be blockchain, other ledger technology, or just some database if it's fit for a certain use case. And what's interesting about DID scheme, so here we have DID methods. Basically, DID method is it refers to some specification that tells us how DID should be used. And specifically, usually it refers to what verifiable data registry used, what operations are supported for this DID. Does it support deactivation, some update operations, and so on. And yeah, in scope of our webinar, we'll be talking about Hedera DID method. So here's an example of DID documents. Apart from public keys that are related to DID subject, it also can contain service endpoints. For example, some issuer can have a DID document which tells what public keys should be used to verify issuer signatures. And for example, what endpoints, service endpoints can be used to talk with an issuer, to integrate with it, send a message, and so on. So how these both concepts work in action? So yeah, here's the same diagram with 3 roles: issuer, holder, and verifier. And we have issuer DID1. So issuer DID is public, and it also tells us what public key was used to sign a verifiable credential. So in this case, issuer has a DID1 and holder has a DID2, and issuer issues a verifiable credentials to a holder. So it signs claims about the holder and sends this data to a holder. So issuer DID is usually on a blockchain or a trusted web service. It can be DID web, so these are DID methods. It can be DID web, DID Indy, DID Hedera, and etc. And holder also has a DID that is used to prove ownership by signature of a holder during the presentation. So holder DID is embedded in verifiable credential and signed by issuer. So holder needs to also to prove using his DID that he actually owns this verifiable credential, that it was issued to him. The interesting point here is that, of course, we can have a unique holder DID for every issued verifiable credential or even for every verifier, just to prevent some correlation and improve privacy. It depends on specific credential format, but still. And holder DID, DID2, is either public or private. Usually it's private because being public, so making user DID public may create some issues with GDPR, but yeah, usually it's private. It uses some self-resolving formats like DID-key, which directly contains public key that was used, DID-peer, and etc. The next, that's it for SSI concepts. So I hope if you have any questions, you can just submit them in chat and we will get back to them. About AnonCreds. So AnonCreds, or anonymous credentials, are a type of verifiable credential that supports advanced privacy preserving capabilities through the use of zero-knowledge proof cryptography. And in short, what are the benefits? So use of zero-knowledge proof really enhances privacy protections available to the holder in presenting data to verifiers, including blinding issuer signatures and use of unrevealed identifiers for holder. So when we use AnonCreds in all these flows that we were talking about, issuance and presentation, there is no way to correlate specific holder, for example. The good example is multiple verifiers. So multiple verifiers will not be able to correlate a specific, that they received a presentation from a specific holder on a protocol level and on a credential type level. So if holder just shares all the data with them, well, they can correlate him, but if holder just shared some predicate that, for example, is over 21, they will not be able to correlate him. AnonCreds supports predicate proofs to reduce the sharing of personal identifiable information. And it has a verification mechanism that works without revealing correlatable identifiers. So verifiable credentials can be revoked. AnonCreds supports this. It's actually the most complex part of AnonCreds, but I think it's enough just to say that this mechanism works without correlation. And as you can imagine, so usually for revoking certificate, for example, we can use just revocation list. And in this case, we don't want to have correlatable identifiers as well. So for AnonCreds, it's more complex and privacy preserving mechanism. It also has complete flows and defined data models for issuance and verification of verifiable credentials in a standard. So AnonCreds is a set of specifications and implementation, and fully defined applications of cryptographic primitives. So all the cryptography is implemented in current implementations of AnonCreds. Works great, no need to worry about it as a developer or as an integrator. Yeah, the next is what is ACA-Py, why we're building plugins for it, and what its main advantages. So ACA-Py is a configurable and extensible non-mobile ARIS agent that implements an easy way for developers to build decentralized identity services that use verifiable credentials. So it supports a lot of standards, has a lot of features, but main advantages from our point of view, and basically acknowledged in the community, that ACA-Py is a batteries included and easy to use agent implementation. So it supports all relevant protocols and standards, either out of box or via plugins. It's used directly via HTTP API and designed to integrate with controller application that can be built with any language. So to work with ACA-Py in your system, you don't need to learn how SSI works or to directly integrate with its code base or protocols. You can just build a controller application with any language that you want that will just do some API calls to ACA-Py and work with it. And control application can be as simple as needed. It's actually possible to use ACA-Py just using Swagger doc and just making the calls from there. It's not very convenient, but still works out of the box via HTTP API. And it essentially can be installed and run as PyP package. Extensibility, ACA-Py supports plugins for adding new DIT methods, protocols, and completely custom functionality. And maturity and stability. ACA-Py is extensively used in production environments. And yep, we've got to the part about Hyero project and Hedera Ledger, and I'm passing the microphone to the Keith.
Hello. Yeah, thank you, Alex. So, this starts with, the journey started with Hedera. For those of you who don't know, Hedera is a public ledger or a L1 blockchain. We've been around for quite a few years, and we've been on open source for most of that in terms of the blockchain stack. But then just recently, we created a new LF within the LF Decentralized Trust organization. We created a new project called Hiero, and we moved all of our source code into Hiero. So if you go to Hiero today, you can find all of the source code for the Hedera blockchain, sometimes also called Hashgraph. And also you can find a lot of the application layer projects that are built on top of Hedera also reside there, including projects like these self-sovereign identity projects. So yeah, I would encourage all of you to go check out Hiero and take a look at the repos. And if you are interested, we'd even love contributors and reviewers to help join the project. Next slide, Alex. And this is just, as I was talking about, Hiero and part of the decentralized trust network. I think I covered most of this. So next slide, Alex. And then what is Hedera? So as I mentioned at the beginning, Hedera is a fully open source proof of stake public network. It's, some of its major attributes is that it's very fast, up to 10,000 TPS. It's very energy efficient, carbon negative. And then, we have very advanced consensus algorithms that, provide things like ABTF security. So a very secure network. And then, of course, around the network, we provide a lot of tooling to support developers on the network. And that includes things like SDKs and other tools. And in particular, for the conversation today, as I mentioned, we also have, these identity SDKs, which allow people to build using popular identity frameworks like AnonCreds, allow you to build upon Hedera. Next slide, Alex. The Hedera network, like many blockchains, we're actually made up of many different services. For example, like we're an EVM compatible blockchain. So we have a smart contract service. So just like Ethereum or other EVM networks, you can deploy and run, smart Solidity smart contracts. And we actually do support Besu, which is another another Linux Foundation decentralized trust project on our network. We have other services like the token service. So on Hedera, you can deploy native fungible or non-fungible tokens. But the bulk of our conversation today is around one particular service, and that's what we call the consensus service. And actually, I think there's another slide on that. So the Hedera consensus service is quite unique within the blockchain world. What it is it's a service that you can start by creating a topic, and then you can publish messages to that topic. And those messages can have any payload you want. And those messages can contain any payload up to 1024 bytes. It's extremely high throughput. It's very scalable. It's very low cost. So it's very aligned with the needs of the identity community. And it's very flexible. So you can write different, any kind of identity objects. And just to be clear, when we're talking about identity objects, let's say in the AnonCreds context or in the SSI context, you don't write verifiable credentials themselves to the Hedera network, but you write objects around the verifiable credentials that support decentralized verification to the Hedera consensus network. A good example, as Alex covered, would be things like DIDs. But actually, in AnonCreds, there's many other objects that we'll go through that you write to Hedera. And increasingly, as we look towards more and more architectures that are zero-knowledge SSI architectures, there will be this need to have objects, whether it's Merkle tree roots or whatever it is, having these objects written to a public ledger is one of the best ways to achieve a decentralized architecture and also make those objects very easily readable, highly scalable, especially horizontally scalable. So it really is a great solution for a lot of these SSI platforms. I think that was it. Is there not?
Yep.
And just maybe a mention on our journey for this ACA-Py plugin. So a lot of the work that we do is community driven. So a while back, we actually had some members of the community. And I think some of them are actually on the chat right now, like Suma from IBM, and we also had another council member from Boeing. They expressed a desire for Hedera support in the popular ACA-Py frameworks, and that kind of kicked off this work. And that was driven by Hedera, and I think Diane might be on this call, and others in the community. We kicked off this work in cooperation with DSR to build these ACA-Py plugins for the popular ACA-Py libraries. And that started with the one that we're talking about today, ACA-Py. And in the future, we're looking to add some other support for other popular ACA-Py libraries as well. And again, this is something that we are contributing to Hiero, so it's all open source. And it just, is basically like a plugin so that anyone using the popular ACA-Py library can just easily set up Hedera as a configuration option and start using the Hedera network to anchor their objects. So we think it's a win-win. We have, like I said, council members who want this kind of functionality, but also we think it's great for the community at large. And I think that's it, and I'll pass it back to Alex.
Thanks, Keith. Yeah. That's about right, and here's our part about Hedera ACA-Py plugin itself. So what it is, essentially, it's an ACA-Py plugin that provides components and integration of Hedera DID method in AnonCreds registry in ACA-Py agent. It's built on top of a Hyero DID SDK that contains Python implementation of Hedera DID in AnonCreds. Here we have identity objects, DID documents, AnonCreds resources stored on Hedera consensus service mentioned by Keith. And this SDK focuses on providing high performance with special attention for read operations, design, and caching strategies. It's contributed to Open World Foundation ACA-Py plugins repo, open source, available for everyone. So internal plugin structure includes following components. It's some common module with plugin setup that registers our implementations and custom endpoints within ACA-Py instance, plus some helpers. It's a separate Hedera DID module that implements ACA-Py interfaces for DID resolver and DID method class, and custom implementation for Hedera DID registrar, and a separate AnonCreds module that implements AnonCreds registry on Hedera using ACA-Py interfaces, integrating in ACA-Py instance, and of course some AnonCreds specific utilities. So talking about plugins architecture, just to take a look at the big picture here. So ACA-Py plugins enable standardized extensibility without overloading core ACA-Py code base. This feature is fully leveraged by our Hedera plugin. And this diagram reflects integration of Hedera DID method as an example. So here we have ACA-Py agent that has some DID method plugins enabled. This, in our case, it's Hedera. It might be checked. It might be did with BH. And our Hedera DID method plugin has Hedera DID resolver and DID register. So resolver is used to read DID documents from the verifiable data registry. In our case, it's Hedera network, Hedera HCS, and DID register is used to create such DID documents and update them. And all our Hedera specific parts, resolver and register, are integrated with Hedera consensus service and Hedera mirror node for data reading. And they're run inside of ACA-Py agent instance. And ACA-Py agent has a routing module where we can modify DID API. So our plugin supports already existing endpoints for DID management provided by ACA-Py. And on the diagram, you can also see agent controller, some small application with admin interface that works with ACA-Py. just for reference. And next is integration with Hedera network itself. So it's a diagram about under the hood integration with Hedera. Main components and layers here are Hedera network, Hedera consensus service integration module, and HCS consensus service integration API used by other modules across the plugin. It's actually built inside of an SDK that I was also mentioning. So what we have here on Hedera network sides, HCS, of course, the consensus service itself, and mirror nodes. Yeah, the important part here is probably that we're reading data from mirror node, and there is some data propagation process in the context of Hedera. And what we have in our integration module, message resolver just to read messages, subscribe to messages from the HCS. We have some implementations of HCS message transactions and a separate service to work with topics, to create topics for the IDs, for AnonCreds objects, and reading topic info. And a separate interesting part here is HCS1 implementation. So as Keith mentioned, HCS stores data in the messages that have a limited size. And sometimes we want to store quite large objects there, some files. There is a Hedera file service, but HCS1 is actually a standard for storing such files inside of HCS, inside of consensus service. It's a great standard. It defines how we should chunk the messages, what kind of compression we can use, what metadata we want to use, and what's also important, what integrity checks are used to ensure that the data that we're resolving from HCS is valid. And important note here is that HCS1 objects that we store, they are designed to be immutable. So we put a file to HCS and we can resolve it, and that's it. But yeah, the standard provides good integrity checks for the data. The next is the diagram about DID management and integration with HCS in this context. So main components here is integration with HCS for all modules, Hedera DID module, implementing Hedera DID, and API, of course. So what interesting part we have here is that Hedera DIDs, according to DID documents, according to Hedera DID specification, these are stored in HCS not as a DID document itself, but as a set of events representing CRUD operations. So one event for creating DID documents, other events for updating some properties inside of DID documents. There might be an event that says the DID document is deactivated, and so on. So regarding this, we have an interesting caching strategy here, because Hedera Consensus Service provides us with ordered messages, and our ordered messages in this case are events related to DID documents. We cache DID document state, current state, and when user resolves a new version, we can just go, and consensus messages are timestamped and ordered. So we can just go and read remaining messages instead of resolving all of them or comparing to other approaches, non-Hedera ones, comparing to resolving the whole document again. And Hedera DID implementation, it integrates with topic service because we're creating HCS topic for each DID. It submits some messages representing CRUD operations, and then we're reading DID event messages from HCS and process them and just get the current DID document state, cache it, and work with cache in such way. And the same integration part regarding AnonCreds module. So this is AnonCreds resources management and integration with HCS. Yeah, the same main components, same approach. So we have AnonCreds module here. And in AnonCreds, we have a set of AnonCreds resources that can be quite large in a size of data, and they are immutable. These resources are credential schema, credential definition, and revocation registry definition, according to AnonCreds specifications. And what we use for these resources is HCS1 service. So this data is stored as immutable files on Hedera consensus service. The only difference is that revocation mechanism in AnonCreds, it assumes not only immutable registry definition, but also individual operations of revoking the credential. These are, of course, multiple events, and these are stored as a separate HCS messages in a separate topic to enable convenient reading. Well, because in sole own identity and in AnonCreds specifically, verifier can ask user to provide non-revocation proof. And this non-revocation proof, he can ask it's relative to a certain timestamp. So this is important, and it is very useful in our case that we store these entries, these individual events of revocation as a separate messages on a separate HCS topic, so we can really conveniently read them. And we also use cache. It's simpler than with DIDs because we're caching HCS1 files that are basically immutable, so no very complex logic here. Yep. Then a small note about documentation. So ACA-Py Plugin documentation has a README and dev tutorial and also a demo guide, and all of that can be found in the repository. All of these are just markdown pages. And then we got to the part with the demo. So the demo that I'm going to show is a console app demo of ACA-Py plus Hedera plugin. It's similar to existing ACA-Py demos. Not very nice UI, but good technical demonstration of how we store the data and how we perform the full AnonCreds verifiable credentials flow, issuance, verification, and revocation. And this demo is a part of plugin code base, essentially. It has a secret folder and it's also available to everyone to check out. Give me a second, I will reshare my screen. Do a demo video. Yeah, here it is. Hopefully you can see it. You should. So yeah, here we have two applications. The left, two console applications. Left one is an issuer and verifier in a single party, and the right one is a holder. So you can see the holder has some context menu here already, and issuer is currently setting up the resources on a Hedera to be able to start with verifiable credentials flow. So we're registering a DID on Hedera, we're registering credential schema for the demo, and we will be registering credential definition as well. Yeah. So credential definition is a resource that, so the schema can be potentially published by any issuer, and for specific issuer to use it, he should publish a credential definition. So it's some schema plus specific issuer DID. And now issuer setup is complete. And what also we have here is that issuer produced an invitation object. So ACA-Py uses DITCOM protocols for such concept as connections. So in order to issue a credential to a holder, we need to establish a connection with DITCOM connections protocol. And issuer just produced invitation object that we need to pass to a holder. In this case, it's done just by copying the text, but actually in real life use cases, it's done using QR codes and other methods. Yep. And now we're going to check that connection is actually established by sending some test messages from both issuer and holder to each other. So you can see that both of them are received the messages. Issuer received it a bit earlier. And then we're initiating credential issuance from issuer side. So you can see that we choose issue credential option on the left terminal. And on the holder side, we can see that it has auto accept for credential offer. It's stored a credential. And we can see that we just got a stored credential data. So we have some claims that issuer provided to us for the demo, age and name. And we have identifiers of AnonCreds resources associated with this credential issuance. So we have schema ID, we have credential definition ID, and revocation registry ID. And you can see that in all these cases, we use the ID Hedera method. So it's the ID Hedera identifier for a specific network. In this case, it's a testnet, and identifier itself, and AnonCreds specific metadata. And of course, the specific consensus service topic that is used to store the specific resource. And then we're going to send a proof request also from on the left terminal, because our issuer is also verifier in this case. So we choose the second option to send proof request, and holder immediately sends the proof. And we can see the proof is valid is true. So issuer got a valid presentation from a holder. And then we're going to revoke this credential and see how it will fail the validation after that. So credential just been revoked by an issuer. And then we're going to send the proof request again. So the holder is provided a presentation, but this proof is not valid anymore from issuer perspective. And that's it for the demo. I will reshare my screen and show you a bit of how the data is stored on HCS. We don't have much time, so I will do it rather quickly. You should see my browser. So I opened the Hashscan. This is a great explorer for Hedera, and we're viewing a specific topic on a testnet that was used in the demo. And this is the topic of our credential schema for the demo. So we can see the schema data here. So Hashscan automatically resolves HCS1 content, which is very nice. It also validates integrity checks. Yep, so our topic contains HCS1 specific header here that has a hash of payload that we need to validate, also compression method and encoding. So you can see the schema here. And we can see how the message itself looks like. So this is the data that was already parsed by Hashscan. And the actual message is we have an ordering index for a chunk. So sorry. So HCS1 data messages are chunked. This is ordering index. So this is the first and the only chunk. And here is the data itself. And in comparison, we can take a look at credential definition, which is larger file, way larger. And this one is chunked already. So we have multiple chunks here in messages themselves, but HCS1 data resolves well, and it just gives us the JSON file that we posted on our network. And let's go back to the slides again. Yep. So that's it about the demo. What are the benefits for community from our point of view? Maybe a bit specific for ACA-Py and self-sovereign identity, but still. So there was a network, it already reached end of its service in March 2025, called Sovereign. It was an Indy network, very stable and very trustworthy, and was extensively used. It was a good option to build production-ready self-sovereign identity solution and use sovereign network with DID Indy, with Indy DID method. And Sovereign reached under its service, as I mentioned, and there is a selection of identity applications and platforms that are looking for a new, trusted, and stable ledger to use. Sovereign network was really stable. It was working without issues for 7 years and without significant DevOps support even. And many of these ecosystems that need alternative, they also use ACA-Py in production or pre-production environments. So migrating to another ledger is much easier than moving to a completely new agent implementation and or SDK. And Hedera ACA-Py Plugin provides an option to use highly performant Hedera network, bringing speed and low cost of operations to decentralized identity use cases. On part of reliability, there is a large network that being trusted and successfully used for many use cases, while also having a large and active community. And we expect it to be a great choice for both existing and new ACA-Py deployments. Yep. And what's next? Our development roadmap. So Keith already mentioned that we're adding Hedera support to other SSI frameworks. Specifically, we're adding Hedera support to OpenVault Foundation Credo framework. This includes new Hyero DID SDK JavaScript hosted under Hyero GitHub organization that will be created. I mean SDK, of course, not Hyero. And Hedera Credo plugin to be contributed to OpenVault Foundation. We're also going to work on official Hedera AnonCreds method specification. So we'll have an official specification for how we store and manage AnonCreds resources on Hedera. And of course, in our plans, future adoption of relevant standards, changes, AnonCreds 2.0 potentially, and Hedera DSpec updates. Also, a small announcement on upcoming events. So there will be a presentation at Global Digital Collaboration Conference in Geneva on July 2nd. It's a Hedera, IRA, and DSR collaboration demo of first-person credentials project. Interesting project with interesting concepts addressing AI impersonation issues and related risks using self-sovereign identity. So you can check out GDC Day 2 agenda. Here is the link. And see first-person credentials and trust in the open source supply chain session and 4:20 p.m. local time. Also, please join the community for the news and updates. LFDT Discord channel. You can see Hyero channel section and Hyero DID SDK Python specifically there. And OpenVault Foundation Discord channel, you can see ACA-Py channel. It includes ACA-Py plugins discussions, so everything related specifically to Hedera ACA-Py plugin can be discussed there as well. Here are some links and technical resources. Yeah, the slides will be shared in the blog post, of course, as Thomas said. So yeah, hope you can find it and take a look if you're interested in something from here. Yeah, the interesting point here is that we have architecture and implementation details for this work inside of Hyero DID SDK repository. So you can see design docs located in the repo and take a look. Here are also our contacts, my email and Discord name. I can be found on LFDT and OpenVault Foundation channels, and email of Keith. Also will be in shared slides. And finally, Q&A. So do you have any questions? Yep, I see that Jim.
There you go. Aurelian is saying that they have a question. Let me just see. There you go. There's a question. Aurelian, the floor is yours.
Hi, can you hear me?
Yes.
Thank you for the nice and clear presentation. I have a few questions, but I think we don't have much time. First of all, I would like to ask if DCR, from DCR perspective, what is the most significant competitive advantage, let's say, of using Hedera and VDR especially in the context of European Union, where GDPR regulations are, let's say, very strict. How Hiero and Hedera position themselves to facilitate compliance in this landscape?
I will say, first of all, about GDPR. So GDPR concerns are more related to how we build our system and whether, for example, or not, we are making holder DID public or any holder or user-related information public, and whether we put it on the chain. So it's not really about specific ledger or specific verifiable data registry. It's more about the concept and how we build our systems. So basically a bit on another level. And regarding what are the competitive advantages of Hedera, well, it's really fast, really cheap transactions. So it's really a great option for verifiable data registry and consensus service along with all the standards, HCS1, and with our Hedera AnonCreds method that we're going to create official versions of it. Yeah, this is just a great option in terms of performance and costs, first of all.
Have you made some tests regarding the scalability? Because many blockchain projects are well, I said, the beginning when there are not so many transactions and users, but at scale can become difficult.
Yeah, I think that Hedera has really good stats on that. Keith may correct me. I think there are a lot of tests on that on Hedera.
So we've seen a Hedera consensus service, has run in production at like 3-4K TPS, and it's capable of going up to 10K TPS. I think there are some other performance considerations when we talk specifically about identity, like we have to resolve these AnonCreds objects. That's why I think earlier in the slides, Alex was talking about things like caching strategies and things like that, how we increase, in particular, read performance for these identity objects. But yeah, we think that blockchain, Hedera's blockchain does provide a very scalable solution, and I would also say scalable not just in throughput, but also horizontally scalable, because anyone can set up what we call a mirror node for the Hedera network and like set up their own service. You can basically not have any bottlenecks on reading data from the network.
Thank you. And only one last question, because I'm a bit in the field, let's say, of decentralized infrastructure, the PIN, how it's called, network, and regarding to the identity. For example, I'm a bit involved, let's say, in Bird Network. I don't know if you heard about that, but it's a decentralized virtual private network based on, of course, of users devices and sharing bandwidth. So that network provides anonymity based on, let's say, residential IPs all over the world, 200,000 nodes across the globe. So do you think a synergy, do you see any potential in this type of synergy, like decentralized digital identity and anonymity in terms of internet access and traffic? Now still,
I think we'd have to understand more about it. I mean, certainly like IP privacy can be a component of decentralized SSI. So I would say maybe I think we'd have to understand more about sorry, I'm not familiar with this Bird service, so we'd love to find out more.
Yeah, because what I mean is that you still, let's say, your internet service provider could see that you communicate data, let's say, this type of identity and so on, with that ledger and so on. So this traffic can be somehow tracked. So another layer, it would be like to have decentralized component to anonymity to regard to how you access over the internet Hedera and the project. Thank you.
Thank you, Aurelian. And I see we have another question, but unfortunately, we're going to have to wrap up. Thank you very much, Alexander and Kit. And Alexander shared the contact information on one of the slides. So when you get to our webinar library, you can see the slides, and then feel free to also reach out to them, Aurelian, so you can continue this conversation, and Jim as well. And apologies again, but we do have to wrap up. You're also welcome to join our Discord, and you can also ask your questions there. We do have a dedicated Discord channels for that. Well, just to conclude, Alexander and Kit, thank you so much for sharing this great information, and thank you for everybody joining us live here. And again, for those of you that we didn't manage to answer your questions, feel free to reach out to Alexander and Kit. Before we go, I would also like to invite you to have a look at our events page, so you can see the upcoming webinars. We have one with MITRE next week, and there are also the live events there as well. I also like to invite you to have a look at our meetup page, and you also will be able to find both live and online events happening in June, July, and later on in the year. As mentioned, please join our Discord channel. There's a lot of real-time interaction going on there. So if you have questions about any of LF decentralized projects, as well as special interest groups or other parts of our ecosystem, you're very welcome to join our Discord. And for the people watching and would like to join as corporate members, feel free to contact us at ecosystem@lfdecentralized.org. Thank you, everybody, for watching, and thank you so much, Alexander and Kit, for sharing this great information. And thank you for everybody watching both here on Zoom, as well as on LinkedIn Live and YouTube. And hope to see you for the next webinar again.
Thank you.
Thank you. Bye, everyone. Thank you for your